Thank you for having me here today. I'm Aleksandar. I work for the company called Reactive. I have 7 years of experience, so that means that I'm second generation double, as Uncle Bob has it. My GitHub handle is Saleh18, sorry. You can find it there. You can also find me on Twitter via the same handle. I'll just quickly say a few sentences about my company. We are Reactive. We are a Swiss-based company having offices in Zurich, Belgrade, and Kruševac. We are mostly working on web solutions and IoT solutions for our clients. You can follow us on social media. Our marketing girls will be really happy if you do that. So today I'll be talking about synchronization of state and view, how different frameworks sync model and the view, the UI, what are different strategies to do that, how we did it in the past, and how we might do it in the future. This will basically be like the historical timeline of my career, because I went through most of these frameworks as they changed and advanced. So we have a simple problem. We have our state that we have to show in the UI. And most developers take this for granted. In Angular, React, Vue, you just have to change some data, you have some data, and it's magically transferred to the document object model, DOM. In this case, this is a simple, pure function. You just take it and create a document object model, but things get complicated as your model starts to change. If you add properties or remove properties from your model or change something, DOM has to reflect that. And that's the tricky part. How do frameworks figure out what has changed? And how do they figure out when is something changed, or when should they check if something changed? So basically, we'll go all the way back to the server-side rendering. And I'm not talking about server-side rendering as you know it today. I'm talking about good old request response when we actually didn't have any client state on the client. Because with each request and response, client state was recreated. Front development was easy. There was a bit of JavaScript probably sprinkled on top of web page, but you didn't have any state on the client. So the state was completely on the server side. And after that, we have Jquery. I know Jquery is not a framework, but I think it really brought a lot of people to JavaScript world, and it's responsible for the JavaScript as we have it today. Like everyone is using JavaScript. So is anyone here who didn't write something like this in his or her career? So you're probably back-end developer, or yeah. I'm not proud of this code myself. But I think everyone went through this phase when we had Jquery manipulating the DOM directly. The problem with this code is that we are thinking about the problem itself, and we are thinking how to update the UI at the same time. So we are actually spending 50% of our brain power to think how we should update the DOM. These are the problematic lines. Nowadays, we take this for granted, but this is how we did it. And we shouldn't think about this. We shouldn't think about the DOM. We should just concentrate on our problem. Here, we are trying to sort table rows, and that's the only problem that we should focus on. In order to solve this, first JavaScript frameworks came along. One of the first ones was Backbone. Backbone gave us a nice way to separate view and the state. Is there anyone here who uses Backbone still? I can't see anyone. That's fine, perfect. I know some companies that still use it. Problem with Backbone is that it doesn't know when your model changed. Or it does know when your model changed, but you have to render the change in the DOM yourself. So it's left up to developer to decide when to call the render function. As you can see here, we have listener on our model, and we are listening for sync and change events, but we have to call a render ourselves. The problem is most developers will probably misuse this, and they will have some timing calls, render this or render that. And Backbone documentation, Backbone primer, has this nice explanation how this should actually be used. Manually timing render calls is prone to errors and inconsistencies. Instead, rendering should be a simple union of data and display. This is really important. Rendering should be just a simple union of data and display. It sounds simple, but actually in practice it's not, and a lot of developers struggled with this. And when the data changes, the display updates. So again, this should be like the only use case where you should actually call a render. In order to mitigate this problem, other JavaScript frameworks emerged. Ember was the one. So Ember now does the rendering for you. You change something in the model, the DOM is updated automatically. But this comes at a cost. This is not without the price, of course. So you have to use Ember object. You have to take the Ember object from the Ember framework and extend it. Uncle Bob wouldn't be happy with this solution at all. That's bad, because developers, they don't want to work with this specific data model API. We want to work with plain old JavaScript objects instead. New frameworks came again. Angularjs, of course. I think there are some people working with Angularjs. There has to be. Angularjs brought a lot of new stuff. First of all, let's try to explain how AngularJS detects changes. In AngularJS, you can use plain old JavaScript objects, so it doesn't force you to use any specific data model from the AngularJS. So it has to detect changes somehow on your model. Whenever you bind something in the template, AngularJS takes that expression and creates a watcher function. Watcher function basically does dirty checking. It compares the previous state of the object with the new state. And each time something changes, AngularJS calls all the watchers. And this may seem like a performance nightmare, because every time something changes, you have to call all the watchers. But actually, it's not. It's really fast, because you are only checking referential equality. So in order for AngularJS to find out what has happened, it has to compare previous state and the next state, so it's called dirty checking. Also, AngularJS forces us to use custom directives. It forces us to use HTTP service, timeout service. So you can't actually use browser native API. If you want to use set timeout without timeout wrapper that AngularJS provides, it just won't work without you manually calling scope apply. What these specific AngularJS directives do, they smartly wrap this functionality and call scope apply for you. And if you did any work with AngularJS, I'm sure you found many, you saw this error many times where it says digest cycle is already in progress, the maximum digest cycle count is reached, and so on. AngularJS also has two-way data binding. That turned out not such a great idea. Two-way data binding means that any change in the model will trigger change in the view, and vice versa. So the change in the view will trigger the change in the model, which in turn will trigger the change in the view. So you end up in an infinite loop. Not a good thing. So in order to figure when changes are stable, when there are no more changes to be seen via dirty tracking, Angular has to rerun watchers until all watchers are stable, like 5, 10 times, or whatever. So, Angular. Angular, as you know, is a completely different framework than AngularJS. They only share the name. Angular is much smarter about change detection in general. Angular doesn't have two-way data binding anymore. It has unidirectional data binding, and this is really important. That means that change in the model can trigger change in the view, but not the other way around. So change in the view cannot change the model. This allows Angular to do only one pass over the watchers, over the changes. So it doesn't have to call watchers until everything is stable. It can only do it once. And as we saw in AngularJS, we have to use custom directives, HTTP service, timeout service. In Angular, they have Zone.js. Zone.js basically monkey patches all the native browser APIs, fundamental methods, and triggers the Angular tick, or triggers the change detection, tells Angular, hey, something has happened, see if something has changed, and update the DOM. Also, Angular creates a custom change detector class for each component, and it can actually do it ahead of time. So if you have Angular application with AOT enabled, you can have change detector generated before and during the build time. And this is really huge performance boost. Then we have React. Everyone knows React. React is really simple. It's someone would say React is not a framework, React is a view library. Yeah, I would agree. But in React, the only way to tell React that something has changed is calling the set state. So in your listeners, if you want to change state, you call set state, and then React knows, hey, I have to check, I have to re-render everything. And React doesn't actually check your model. It doesn't observe the changes in your model. It just re-renders everything. And how it does it? How it does it fast, actually, by using virtual DOM. So each time you call set state, your model is changed, and the virtual DOM gets updated. Virtual DOM is basically just a virtual representation of the real DOM. So the access to the virtual DOM and diffing between previous virtual DOM and the new virtual DOM is really fast. You don't want to access the real DOM until you really need it, because those operations are extremely slow compared to the JavaScript objects. So React takes the new virtual DOM that was created and compares it with the previous one, finds the minimal difference that has to be patched onto the real DOM. And that's it. Now, with the introduction of hooks, you'll hear more about that after lunch. React actually got a bit more reactive. You can use hooks in the functional components, but yeah, we'll leave that for after lunch. After React, I've worked with Vue.js for some time now, and Vue.js is currently my favorite framework, if I can say so. Vue.js is a different beast completely. If you tried Vue.js, you had to come upon this image. It's in the Vue guide. It tries to explain how reactivity in Vue works. What Vue does is it takes your plain JavaScript object, your data object, and magically creates getters and setters. I say magically, but yeah, it creates getters and setters for each property in that object. Whenever that getter is accessed in your templates, in your render function, this property is collected as dependency. Whenever that property is changed, watchers are triggered in order for Vue to know that it should re-render something. And again, Vue has virtual DOM, same as React, so it doesn't touch real DOM until really needed. And the cycle is repeated. So let's try to explain with a bit of code. This is like really simple implementation, naive implementation of what Vue does. It's just here as a comment. So this is the place where Vue can collect dependencies on the property. It's just an object-defined getter. Also, we have object-defined property setter, where we notify watchers. So this is the place where reactive system kicks in and injects Vue reactivity. There's a problem with this approach, of course, because with this approach, we cannot detect everything. There are some things that are just not possible to detect with this. One of them is adding of the new property, because that's not the setter. Vue can only work with existing properties. So if you want to add a new property, you have to call Vue set. And if you want to remove property, you have to call Vue delete. Also for arrays, Vue cannot detect that you've assigned item for a specific index in the array. That's impossible for Vue to detect. And if you modify the length of array, also no help there. So I think you might have noticed the difference between Vue and the previous frameworks, React and Angular and Angularjs. And that's pull versus push strategy. All the previous frameworks that we mentioned here used pull strategy. Pull strategy means that we have to tell the framework when something has changed. We have to have explicit signal where we say, hey, framework, something has changed. Do your magic. Try to find the difference. Render that to the DOM. In AngularJS, that's calling scope apply. That's wrapped in the Angular directives and services for you. So you don't see it, but you can use it if you want. Or application reference tick in Angular. Or set state in React. So you have to have explicit signal. In Vue, in contrast, you don't have that. Vue is directly observing changes on your model, on your state, and applies necessary changes. This is called push strategy. This is explained by Hollywood principle. Don't call us, we'll call you. This basically allows Vue to skip work. It knows that exactly this property has changed, so only the computed properties, only the properties that actually depend on this property should be recalculated and should be re-rendered. So Vue knows exactly what to re-render. It doesn't have to re-render everything like React, or it doesn't have to have dirty checking, stuff like that. But in the wild, in the real world, you can have a mix of both. You can have a mix of pull and push strategy, and that's what a lot of people actually do. In Angular, you can define on push detection strategy, where you say to Angular component, yeah, don't re-render this until inputs are changed. In React, you can use React plus Mobix. Mobix actually uses almost the same reactivity system as Vue, so I encourage you to take a look if you're using React with Redux. And if you're considering a new project, take a look at Mobix. It might prove valuable to you. And of course, you can use Vue with immutable data, in which case you would have to tell Vue when something has changed, because Vue wouldn't have any means to detect that something has changed and that it should re-render something. So There are some things happening in the Vue community. They are preparing version 3. Mobix, as mentioned before, has already done that. What they're doing, they are rewriting complete reactivity system using proxies, and I'll explain why this is the better solution than getters and setters that we saw previously. So here's a proxy. It came in ES6 edition of JavaScript. Proxy defines like the proxy object that takes 2 arguments, target and handler. Target is your base data object, and handler just defines the handlers on fundamental operations that you can do on the object. So it allows you to intercept those fundamental operations and do some work of your own. This is how we define the proxy. We see if we change something on the proxy, yeah, it gets changed. And the most important thing, the target object is not equal to the proxy object. That was one of the problems why they postponed reactivity system rewrite in proxy for some time. So let's try to define a simple getter trap. We have a handler here, same code as previously, but now we've added getter trap. We are trying to intercept fundamental get of property on the object. What we say here is if property is not in the object, return 37, otherwise just return that property. We define new proxy. We assign it values for A and B. And if we console log, everything works fine. But then if we try to access C in the proxy and C doesn't exist as a property, then we will actually get 37. That's where the magic happens. That's where we have this getter that kicks in and intercepts that. So you may see where this is leading. Proxy handler, there are 14 fundamental proxy handler traps that you can use. And we are mostly interested in these 3, getter, setters, and delete property, because that's what we have in the current reactivity system, and that's what we can rewrite with proxies. There's one thing that cannot be skipped when talking about proxies, and that's reflect. Reflect basically defines default operations in the handler. That means that if you didn't define a trap in the handler, reflect will be called instead. So here, we are defining a set trap in the handler, and we are checking if property name is age, and if age is more than 100, we will throw an error. Otherwise, we will return the basic reflect set. So whatever is the default behavior for this trap, whatever is default behavior for these fundamental operations, we don't care. We are not actually going to assign that to the object. We are just going to say, yeah, do the reflect set, whatever that is. And here we can see that it works. Yeah, if we call it with 26, it gets assigned. If we try with 150, error gets thrown, and the value was not changed. Yeah, it's all great and perfect until we have to support Internet Explorer. And who has to support Internet Explorer here? Yeah, I have to do it as well. Not happy about it, but yeah, it's everyone else. It seems like all the product owners and managers are using Internet Explorer. So, because proxies are so fundamental, they can't be polyfilled into the older browsers. There's no polyfill for proxies. They are either there or they are not. As you can see, Internet Explorer is the only one that doesn't support them. So, yeah, if you have to support it, sorry, but you can't use proxies yet. So let's try to do the same thing that we did with getters and setters, and now let's try to redo it via proxies. We will observe changes in our object, and as the second argument, we have listener. That will just be the function that we will call whenever something changes in our proxy. And we will define the empty handler, so just do whatever the basic fundamental operations are. And yeah, here's our data, here is our observed data. We have our callback function, it's just console logging the new value of the object. So first thing, handler get trap. This is, again, the place where Vue can collect dependencies. We do reflect get. Reflect get, just do whatever you are doing with the get. We don't care. We are not actually, we don't want to do target property key. We'll just use reflect get. And if the type of object, if the type of value, the property that we are getting is object, we are going to observe it one level deeper recursively. And we're going to return that value. And then we have the handler set trap. In the set trap, we want to notify our watchers that something has changed. So this is naive implementation. You can check the Vue source code or Mobix source code for more. Again, we'll call the default behavior, and we'll call our listener, our callback, with the new value of our object with the change values. And then we will just return result. OK, so here we have it like everything. From our function, we will just return a new proxy with our object and our newly defined handler. And let's see what do we get as a result. So we have our data. We are observing it. When we change something in our data, when we try to change the property, our callback gets called with the new model. And this one is really important. When we add a new property, our callback, again, gets called. We can detect that now. It's not like with the object-defined property setters, because now we can actually intercept adding of the new properties, and we can intercept as well deleting of the new properties. So all the caveats that Vue now has in its reactivity system are gone with the proxies implementation. So as we can see, our data model is changed as well. So Vue version 3. Vue version 3 is getting rewritten completely in TypeScript, but don't worry. If you're using TypeScript, that's great. I'm a really big fan of TypeScript myself, but if you're not, you can still use JavaScript with it, but its core will be rewritten in TypeScript. And reactivity system will be rewritten in proxies, same as Mobix does already in version 5. So there will be a huge performance boost there, and there won't be any of the problems that we see now in the Vue reactivity system, in the version 2.6 or whatever you're using. So that's a big plus. Also, for people who have to support Internet Explorer 11, there will be a branch that doesn't use proxies. So there will be a reactivity branch that doesn't have proxies in it. So it will still implement the current version of reactivity system, so you'll be able to use it. So I would encourage you, if you're considering a new greenfield project, to take a look at Vue if you haven't used it. Or even if you want to just sprinkle some JavaScript, like the Jquery stuff, something that you would use Jquery for on your website or whatever, you can use Vue. It's really simple. It downscales really well. So I would really recommend it to you that you use it. So I know it's lunchtime and you're probably hungry, so thank you.